As wind-assisted propulsion systems mature across shipping segments, valuable lessons are emerging from early installations. At Lloyd's Register, we've explored how technology and integration practices can streamline sail installations to reduce costs, complexity and risks. With rotor sails representing the most widely installed wind assistance, this seemed like a natural place to start. We've been examining 3 retrofit installations of rotor sails on bulk carriers, all supplied by UK-based Anemoi, whose engineering design manager joins me today.
Each vessel differed significantly in terms of the size, the deployment system and the number and the size of the rotor sails, and this gives us a wide range of insights to draw on. Firstly, the Aphros is a 64,000 DWT Ultramax bulk carrier, and she was fitted with 4 of our Anemoi rotor sails on longitudinal rails in 2018. Then the TR Lady is an 82,000 DWT Kamsarmax bulk carrier, and this started with a 2-phase conversion to wind ready in 2022. The TR Lady needed structural and electrical integration, including our transverse rail deployment system, as well as modifications for ship and regulatory compliance. And then it was fitted with 3 of our Anemoi rotor sails in 2023. And then in 2024, the Sohar Max, which is the world's largest ore carrier, was fitted with 5 of our Anemoi rotor sails, and it's the largest vessel to date to install wind-assisted ship propulsion. The rotor sails are fitted on Anemoi's folding deployment system, which allows them to be folded from the vertical to the horizontal and mitigates any air draft and cargo handling impacts. After the rotor sails are lifted onto the vessel, the system is ready for the Harbour Acceptance Test, or HAT. During this, we check the signals between the rotor, the vessel and our control systems are all working as expected. We also check all safety-related set points in the rotor's control system, including temperature and vibration sensors. We check all the limits through the full speed range. We check all interlocks are working correctly, and we conduct any of the fine-tuning on the dynamic balancing of the rotors. All of these tests and checks during the Harbour Acceptance Test ensure absolute safe and full functionality of the rotors once the installation is complete. And then in service, we provide onboard support during the maiden voyage to address any snags that arise and to provide training for the ship's crew for both the rotor operation and then the deployment systems during port operations. Right from the start, we engage closely with clients, class, flag state and other regulatory bodies to make sure we are anticipating and addressing any issues at the earliest opportunity. Having these relationships and discussions early on in the installation process means that we can find the most efficient route through any compliance and regulatory challenges. We can also draw on our experience from previous projects to anticipate issues and provide some tried and tested solutions to help the industry navigate through the obstacles that are presented by introducing these new technologies to already established regulations.
Each project required re-examination of regulatory compliance aspects, especially energy efficiency, navigational safety and stability. The Energy Efficiency Index, EEXI, is a representation of a ship's greenhouse gas emissions. It was introduced to improve the efficiency of existing vessels, aligning them with new ships of the same age. A sail installation will contribute a net power due to wind assistance when calculating a ship's EEXI. By providing wind thrust and reducing main engine load, a sail will improve a ship's EEXI from a reduction in greenhouse gas emissions. 4 key steps involve importing wind data from the latest IMO Global Wind Probability Matrix, correcting and converting wind data for rotor sail height and apparent wind direction, importing rotor sail performance data specific to the installed sails, finally calculating the rotor sail's effect on reducing required engine power.
All 3 vessels use Anemoi's method for calculating net effective power following IMO's guidance for innovative energy technologies, and this calculation was key in the ship owner's EEXI technical file submission during the rotor sail installation. All of this resulted in significant energy efficiency improvements across the fleet.
A A sail installation has an impact on navigational safety and compliance with the following regulations. IMO SOLAS sets standards of safety for navigation, including aspects such as bridge visibility and radar blind sectors. Collision regulations set standards of safety and include requirements for lights and signals. And finally, Panama Canal Authority's requirements include standards for navigational safety for vessels transiting the Panama Canal and include specific requirements for bridge visibility and navigation lights. The Panama Canal Authority's bridge visibility requirements necessitated modifications to TR-Lady due to obscured forward light because of the rotor sails installed. All vessels fulfilled SOLAS requirements for bridge visibility. SOLAS enforces strict regulations on radar blind sectors. For all 3 bulk carrier installations, this required fitting new forward radar antenna to eliminate blind sectors caused by the rotor sails. Aft masthead lights on vessels over 50 metres must be visible from ahead of the ship by collision regulations. Rotor sails sometimes obscure the masthead light, which requires countermeasures and solutions. TR-Lady obtained a flag state exemption to split the main masthead light port and starboard, and in the case of Sohamax, a vertical main mast extension was made. The regulations require amended stability information if a ship is materially affected by the alterations. All 3 bulk carrier cases required an inclining experiment on sail installation.
An inclining experiment assesses vessel heeling to determine the centre of gravity. It can be conducted during the wind-ready phase or after rotor sail installation. For the TR-Lady, it was performed during the wind-ready phase to minimise shipyard time during the installation. This ensured compliance whilst optimising efficiency at the same time. As manufacturers, we're developing lighter technologies to reduce the wind-assisted propulsion system's impact on vessel weight. Lighter sails may reduce the need for re-inclining, but the rotor sail placement remains critical. If placement changes the centre of gravity by more than 1%, re-inclining is still necessary regardless of the weight reduction.
Loading computer tests were conducted on all 3 vessels to ensure modifications were accurately reflected in the ship's stability software. Once a ship owner has selected a sail and rig configuration, an early discussion is recommended with class to assess the impact of the sail on the ship. This is an essential first step to ensure smooth execution of a sail installation. Basic advice of flag state involved was for the ship owner to try to achieve compliance as far as possible. Then and only then, an alternative can be looked at. In case of non-compliance and once a practical alternative has been decided, the flag state can be approached for acceptance.
The integration of the rotor sails and the interface between the sails, the deployment systems and the vessels always entails an element of structural changes. The implications for the classification of the vessel requires updates and approvals to several of the documents. For all 3 of the vessels, we needed to anticipate potential interference issues, such as any interference with the shoreside or shipboard cargo gear, any air draft limitations for port operations, and any interference or obstruction for deck access. And then we also had to optimise rotor sail configuration based on existing below deck structures and adopt any countermeasures that can help mitigate the risks that these challenges presented.
Through these 3 installations, we found common issues arising for regulatory compliance. Tackling these elements of regulatory compliance early will ensure the modifications required are minimised, or at the very least thoroughly prepared for. It can also minimise scheduling issues for maker and optimise the vessel retrofitting. Being prepared early for regulatory challenges is one element to consider to optimise a sail installation to save cost and time. Since installing this solution, clients have seen up to 15% fuel savings, leading to cost reductions and more sustainable operations. The efficiency gains optimise resources, lower carbon footprints, and enhance productivity, delivering both economic and environmental benefits.
Working in partnership with Lloyd's Register is always a pleasure. The team is professional and incredibly easy to work with. Our collaborative relationship ensures that we deliver exceptional results for our clients. Whether this is navigating complex challenges or meeting tight deadlines, commitment to excellence and seamless communication makes the entire process smooth and efficient.
For Lloyd's Register, working with Anemoi as a partner to deliver sales solutions to clients has been a fantastic experience. Their engineering excellence and deep expertise shines through in every project, and our collaboration enables us to provide our clients with mature and proven rotor sales systems that exceed their expectations. Together, we are driving forward the future of sustainable maritime technology.